So we're going to do example number 5, but we're going to do it a little different. So you need to write this down because it's not exactly the way it is in the book, okay?
For section 2 or 3?
Yeah, so we're on, I'll write that down too. This is 4.3, so we're starting 4.3. There were only 2 questions on the 4.2 homework for 7 and 9. You probably figured it out, but I made a video and I responded and posted it. So anyways, check that out. If you have some questions on the 4.2 homework, post it on the discussion thread, and I'll give you an extra day if you need it, and I'll make a video or whatever. But I think we spent a lot of time on the example, so I think you guys did okay with that. But still, if you have questions, let me know. So we're going to do 4.3. So now, 4.2, we did a thing called the first derivative test. And I didn't tell you that it was a first derivative test because whenever you tell students test, they kind of freak out. So basically what we did is we looked at when f prime was equal to 0. All right, and so what we would do is we'd say, all right, f prime of x equals 0 here, right? And then we would determine if it was negative or positive on either side of what we would call a critical point. And what that told us is that f of x was either increasing or decreasing depending upon the value of the derivative, okay? Right? You guys remember that? So what we did is, and this is a very short, quick version, but basically we had f of x, which was a function. And we said, let's look for the mins and maxes. And the mins and maxes occurred at the critical points. Well, the critical points occurred when f prime equals 0. They also occurred where f prime doesn't exist. But for all intents and purposes, we really try to focus on when f prime equals 0. Okay? And so then we did the first derivative test is to determine when it's positive or negative. So whatever value x was, if I took some negative value that was way less than that, right? Then I plugged it in. If it was positive or negative, we assumed that the function was decreasing, right? And then if we took some value and it was greater than the critical point x value, we would determine if it was positive or negative. If it was positive, then we would say it was increasing. And by the way, this could go 2 ways, right? I could have positive over here and negative over here, which meant that the function was increasing or decreasing based on the values of f prime. Okay? Little review, all right? Does that make sense? You guys remember all that? Okay, so now today we're going to do the same thing, but now we're going to focus on f double prime. And so we're going to find the critical points of f double prime, which is the exact same process we did for f prime. We look for where it equals 0, and then where it doesn't exist. But most of the homework problems now, we're just going to look for where it equals 0. And so this is what we will call the second derivative test. And we would do the same thing. Wherever f double prime of x equals 0, we look to an x value a little bit below and determine if it's positive or negative. And we do the same thing over here, determine if it's positive or negative. Instead of calling this a min or max, we call this point right here a point of inflection. And we'll talk about that. Now this test tells us whether it's positive or negative. This tells us the concavity of f. And you might be asking yourself, well, what is concavity, Mr. Adams? I'm glad you asked. If the value of f prime is positive, we say that it's concave up, which means the function has a behavior that curls up. If f prime is negative, we say that it is concave down, which means the behavior or the function curves down. Okay? We'll draw a picture in a second. Now, the purpose that this serves is we can graph a function, and we'll do one in a second, just through algebra, and fairly accurate too. You'd be impressed with how accurate this graph is, okay? So, can I move on to one more slide? Is everybody writing this down? Because it's not in the book. The book is long and boring and drug out. I'm trying to make it short and quick, but I'm trying to focus on the key points here. And then we'll go back and do some of the other examples once we kind of have a grasp of it. So now, I have this graph, right? And I'm going to draw f of x with this marker. Now, if I start here and I move up, what is the function f doing?
Plus increasing.
It's increasing. Well, let's think about that. If I draw up to this point here, there's two things that's going on. One, f of x is increasing. That means that f prime is positive. However, if you look at how it curls, it's curling down. So that means concave down. So we're going to draw these little symbols. That means increasing. Now if it's concave down, what does that mean? That means that f double prime is negative. So if we look at the red portion of f of x, that's what all that stuff means. Okay? Now if I come in here, and from this point to here, what is f of x doing? Well, f of x is what? Decreasing, which means f prime is negative. Now what is that with regards to the concavity? What does it look like it's doing?
It doesn't look like it's coming back.
Well, here it's curling down, curling down, curling down, curling down. So I'm going to say that it's still curling down, which means that that's negative, right? So, how did I lose my marker? So that means that f double prime is still negative. Okay, you guys with me so far?
Yeah.
All right, let's choose a different color, orange. All right. Now from here to here, what is my function doing?
Decreasing.
Yeah, so it's still decreasing, which means it's going down, which means f prime is what?
Negative.
Negative, right?
Yeah.
But now it looks like it's curling up, which means that f double prime is okay. So if I come back, here it's still curling down, here it's curling up. Now from this point, what is f double prime, or what's the function f doing?
Increasing.
So now f of x is increasing, which means f prime is
Positive.
positive, which means, now what's the concavity of that?
Positive.
Yeah, it's still kind of curling up. So we would say that f double prime is positive.
Yeah.
Okay? Now, let's label some of these points where the curve changes. This is what? That's a local max. What's this?
Global.
Local min. Okay. What's this? Anybody know? Well, this is what I'm teaching you today. This is,
Zero.
no,
Point
point of inflection where the concavity changes.
Wait, but isn't it still done down at that point?
Well, it goes from down to up, right? Here to the left of this, it's concave down, but as soon as we get past this point of inflection,
Oh,
it goes to concave up. So it's like the min or max of y prime, right? Kind of, if you think about it that way. Except we call it concave up or down. Yes?
Why isn't it the point below it? The local min, why isn't that the point of
Because the point of inflection occurs when concavity changes. So here we'd say this is when concavity changes. That word is changes. I was running out of room. So point of inflection is, and I'm going to go to another screen. So let me write all this stuff down. So the point of inflections looks like this. Here's my point of inflection. Here I would have f double prime values of negative to positive. So that means that I am concave down and then I switch to concave up. So at the point of inflection, it can go from concave down to concave up, or it could go from, if my f double prime of x is positive and then it switches to negative, it goes from concave up to concave down. But this always occurs at the critical points of f double prime. Actually, it's when f double prime equals 0, right? Does that make sense?
That's the point of inflection.
That's the point of inflection, where f double prime equals 0. But now, just like before with the other thing, it could also occur when f double prime doesn't exist. But we won't talk about that today. We got to get a grasp of this first. Are there any questions from anyone? All right, so here's what we're going to do. We're going to start with a function from example number 5 out of the textbook. But I'm not going to do it exactly out of the way the textbook is. So again, you need to write this down because I think this is a better way to explain it. The textbook is good, but it's real formal. And since we have a short amount of time in class, I'm trying to condense it and then we'll go back. You guys have a tendency, you like to see how it works together, and then we'll go back and look at the intricate details. Sometimes if I do too many intricate details at first, it confuses you guys.
was your example?
No, it wasn't. So example number 5 is the function x of t is equal to 2t cubed minus 14t squared plus 22t minus 5. Now, if I say graph this, we could plug it in our graphing calculator and it'll graph it, right? But I want to try and graph this by hand, just knowing when it increases and decreases, and when it's concave up, concave down. So I need to find the mins and maxes, the local extrema, and then I want to find the points of inflection. Does that make sense?
Yep.
So now to do that, what do I need to do?
Find prime and no prime.
Yeah. So I'm going to do, this is x prime, which is what? Can you guys help me with that?
6t squared.
6t squared.
minus 28t
Good.
plus 22.
Alright. And I suppose, let's do x double prime now. Alright. So now, the next step of this, if I wanted to graph this just using points of inflection and min and maxes, I need to find the critical points. So the critical points now occur when x prime of t equals 0 and x double prime of t equal 0. Okay. Now, because they're polynomials, there are no domain restrictions. That means t could be any value, all real numbers, right? So this will, in other words, both functions, both x prime and x double prime will be defined at all points. I can plug in any value for x and I'll get a y. Right? And remember when we did 4.2, that was the one little caveat, is like the critical points will occur when the derivative is equal to 0. Right? But they don't occur. Like another place that the critical points can be is when f prime isn't defined. Well, the same thing applies here, but we're just not going to deal with it because these are all real numbers. The domain for both of these, prime and double prime, are all real numbers. So now, I happen to know we know that we could solve the zeros by using the quadratic formula, right? Do I need to reteach you the quadratic formula? No, you guys know it. You know it. So what we're going to do is we're just going to come in here and find the zeros for that thing. So to find the zeros for that function, I'm just going to graph it and let the calculator do the work. Okay? So, hey, there it is right there. Well, what a coinky-dink. All right, so now, if I graph x prime, I just need to find where so that's x prime, right?
Yeah.
6x squared, it's a parabola. I just need the zeros, right, which are the x-intercepts. So if I hit second trace, and I choose option number 2, and I do the right bound, oh, dang it. I hit the button too quick. Let's do it again. Second trace, 2. And I'm going to go a little bit to the left, a little bit to the right, somewhere in the middle. One of my zeros is x equals 1, right? When x equals 1 on x prime, then I get a y value of 0, right? So let's write that down. So if I come here, my zeros for xt prime, so what we're doing is we're saying x prime of t, which was 6t squared. Could you guys tell me the rest?
Minus 28t plus 22.
Plus 22, right? We had zeros occur at 1, 0. That's one of them, and we have one more to go, right?
Yes.
So let's write that down, zeros. Now let's find the other one. So I'm going to hit second trace again, 2. And I'm going to go a little bit to the left of this intersection. I got to go a little further, a little closer. Oh, you know what? It did it again. Let's start over. All right, get a little closer. My increments are really small on my. All right, a little closer. Hit enter. A little bit to the right of this thing. Guess somewhere in the middle. Now, 3.66 is 3 2/3 or 11/3, right?
Yeah.
Yeah. So then, another 0 occurs at 11/3, 0. So here's what I want to do. I'm going to make a chart. On the top line, I'm going to talk about the behavior of f of x. Then I'm going to talk about the behavior of f prime of x. And then what else do you think I'm going to talk about? F double prime. So right now, what I know that f prime has a critical point at x equals 1 and another critical point at x equals 11 over 3. And so now we're going to do the positive, negative, positive thing, right? Well, now if I go back, my y prime or f prime, or in this case x prime, is positive on the outer boundaries, right? And then it's negative on the inside here. Is that right?
Yeah.
Does that make sense? Yeah. Now we could plug the numbers in. In other words, what I would do is I would come in and I'd plug in a number less than 0 or less than 1, like 0, and then I would get a negative value, right? So here I would have like it's negative here, or no, I'm sorry, it's positive here, and then here it would be negative, and then here it's positive. Is that right? Based on the graph, right? Did I do that right? Here we have positive values, here we have positive values, but down here we have negative, and these are the zeros. Does that make sense?
Yeah.
Positive, negative, positive. Okay, so now that's good. That was pretty easy, right? Now what does that tell us about f of x? Well, what it tells us about f of x, that when x equals 1 and x equals 11 over 3, it's increasing, decreasing, and increasing, right? If we talk about the graph f of x, does that make sense? Does anybody have any questions? If you do, raise your hand, interrupt me, yes.
Because, well, yeah, but when it's increasing before x equals 1,
Mm-hmm.
isn't it decreasing down to 0 and then it's scooping up?
I'm talking about f of x.
Oh.
What do I have on the screen?
Oh, that's x prime.
That's x prime, right? And I'm sorry, I keep saying f of x, but you guys know that we're dealing with the x prime, and x double prime.
Yeah.
Okay. Sorry, it's just kind of a slip. Yes?
Is that just like a thing like f of x to f prime of x? Like if f prime of x is positive, then it'll be increasing on f of x?
Yeah, that's exactly what we're talking about. So I'm going to restate what she said. She said, is f of x increasing because f prime is positive? Yes. And then it's decreasing because the derivative, the first derivative, is negative. So you know what I'm going to do, just to, because it's bugging me a little bit, I'm going to change this so that it's written properly. It's actually x of t, x prime of t, and then x double prime of t. All right. So now, remember, our goal is we're going to look at this chart when we're done, and we should be able to graph x of t without. We should be able to graph it by hand, just based on the curvature and the mins and maxes. Okay, that's our end goal. So now, what do we need to do? Now we got to do x double prime. So now, if we come into the double prime. Those are the zeros of x prime, but now I need to find the zeros for this. Does that make sense? Okay. So let's write that down and figure. I mean, I already know what it is, but let's write it down and go through the process. So if I say x double prime of t is equal to 12t minus 28. I suppose I could use the calculator for that. But we know that it's 12t equals 28, or t is equal to 28 over 12. And if you divide the top and bottom by 4, you get 7 over 3, right? How could I verify that?
A calculator.
Calculator. So if I come in here, and I'm going to graph it separately. So I'm going to turn this function off, because really I want to be surprised at the end, right? So if I come in here, guess where that crosses right through the crosses right here, I think. In fact, we're going to double check it. I'm going to hit trace, and I'm going to enter in 7 divided by 3, y equals 0. It's like I'm a mathematician or something. To the left of that, what is this y value? Like, what is the value of this? What is, yeah, it's negative. So x double prime of t is negative. And to the right of that, what is it? Yeah, x double prime of t is positive. Does that make sense to you guys?
So is that where it's concave?
Yep. So yeah, don't get ahead of me. Well, I mean, you can, just don't. So where does 7/3 occur?
Between 1 and 11.
Yeah, it's somewhere in the middle here, right?
Sure.
And we said it was negative here, right? Which means it's concave down. And then we said it's positive here, which means it's concave up. All right, we're almost there. All right. So now the only thing I want to do is I want to figure out what these points are on my function f of x, or in this case, x of t. Right? How do I do that?
Plug it in.
I just plug it in. So what I'm going to do is I'm going to come to this function, but I'm not going to graph it. I don't want to graph it. So I'm going to go, I'm going to turn, I've already got it plugged in because I did this problem last hour. But I'm going to turn it on, but now I'm going to hit second table. And I'm interested in 1 and 11/3 and 7/3, right? So if I go up to 1, this may take a second. So when x equals 1, what does y equal? Now you guys understand that this is this is the original function, right? So I've got 1 comma 5. So over here, if I say x of 1, it equals 5. That means the point 1 comma 5 exists on the line. Next, I'm going to find out what x of 7/3 is. So I'm going to plug that in my calculator. It's negative 11. Got a question? What's your question?
Yeah.
Wait, no, it's not negative 11.
Oh, wait. That was of 3, wasn't it?
That
Yeah,
was
I'll come back. What's your question, though?
The equation that you plugged into the calculator was x of t.
Yeah, so what I'm doing is I'm plugging, in fact, let's just do another, somebody tell me what that was. What was it? X of t was,
2 t to the third
No, 2 to the third.
minus 14 t squared plus 22 t minus 5.
right? Wasn't that what it was? And so now what I'm doing is I'm plugging in the critical point. So I'm trying to figure out what x of 1 is, what x of 7/3 is, and what x of 11/3 is. So I'm just going to take those values and plug them in. And what that tells me is that the point 1 comma 5 occurs on the line. So does that make sense what we're doing? All right, good. Let's figure out these last two. So 7/3 is 2 1/3, right?
Yep.
Which would be
Negative 4.
2 1/3. It would be like negative 4.48. So let's just call it negative 4.5. So let's come in here and we'll say negative. Whoops. Let's do the same color. Negative 4.5. We're estimating, and you'll see why it doesn't. I mean, it's important, but I'm trying to go quickly so you can see how all this stuff connects. And now let's figure out what 11/3 is, which is like 2 2/3, right? 2.66? Or no, 3.66, right? So let's do that. So 11/3 is 3 2/3, or 3.66. So it's about minus 14, right? Okay, so I'm going to come in here, and this is about minus 14. So roughly, we got this, right? Now, we got to remind ourselves, what was this, and what was this? Well, let's go back. Where did we get the 1 from?
The 0.
Yeah, so this is a min or max. Which one is it? If it's increasing, then decreasing.
Max.
This is a max right here, right? And then what's this one here?
And
A min. So let's go back and label those. So this is a max, and this was a min, right?
yes.
Does that make sense?
Middle one is the point of inflection.
All right, so now, yeah, I think so, but I just want to double check. So, and then this was a point of inflection, right? Okay.
Yeah.
Now we're going to see how it all comes together in just a second. And do you guys remember one thing? What does this tell us? Does anybody remember what that tells us?
Is the y-axis, right?
This is the y-intercept, yep. Do you guys remember that?
I do.
That's the y-intercept. So really, I have 3 points, because this one is, or 4 points, 0, comma, -5. You guys ready? Gonna graph it by hand.
Why would we do that?
Well,
Because it's
well,
fun.
why would we do that? I wish I could videotape your guys' the looks on your faces. All right, so now I'm going to come in here and I'm going to turn the graph off, and I'm going to set my window. What should we set our windows to? Our x values go from what to what?
1 to.
Yeah, so let's do like -1 to 4, right? We don't have an x value greater than that, do we? So for our x values, did we have an x value greater than that? No. We had 4, so let's just go from -1 to 5, right?
Yeah.
So what Mr. Adams is saying is like, look at all of our x values. None of them are greater than 5, and the lowest one is 0, right? If we look at all these x values, okay? So I'm setting up my graphing calculator from 1 to 5. Now if we look at the y values, I go from 5 to -14. So I'm going to say -15 to 15. Is that okay for y? All right. So now, that looks good to me. Let's see. Is that, yep. Yeah. So now I purposefully turn the graph off. Let's plot the points. So we have the following points. We have the y-intercept of 0, 5, or 0, -5. So I'm going to go 1, 2, 3, 4, 5. This is on the line. Then our next point was 1, comma, +5, right? So we're going to go 1, comma, 1, 2, 3, 4, 5. This was a point here. And we said that was a max, right? Okay, good. You guys with me so far? Then we're going to plot the point 7/3 minus 4.5. So that was 2 1/3 and then minus 4.5. So about right here, right? And we said that was a point of inflection. And then we have the minimum right here at 3 2/3 and minus 14, right? So 3 2/3, so 1, 2, 3, 14's about right here. And we said that was a min, okay? Now, the only thing that I need to remember is that at my point of inflection, so now we got to go through and look at some of this stuff. My point of inflection, everything to the left of my point of inflection is concave down, right? It's concave down. and everything to the right of my point of inflection is concave up.
Oh,
Does that make sense? Do you have a question?
Yeah, where did the 0, -5 come from?
That's the y-intercept.
Oh,
Because the function ends at, if you look at x of t, it ends with -5. So if you plugged in 0 for t, all those other terms go away and you're just left with 0, -5.
okay.
Okay? So now here's the thing. Everything to the left of this line, the function is going to curl down. Everything to the right of this line is going to curl up because of the concavity. That's based on f double prime. Right? You guys with me on that? Any questions? Does that make sense? Now, what does the function do to get to the max? Well, if I look at this, here it increases. That's based on f double prime. And then in the middle, it decreases. And then over here, it increases again. Does that make sense so far? So now how would I draw this curve? Well, it's concave, it's increasing to this point, and it's concave down. So it should sort of go like this. Well, I drew it wrong. It should sort of curl like this. Right? Now it's still curling down up until this point, so it should come through like this. So really, it should kind of curl like this. Right? That's how it should look, right? Going through this point right here. Now what does it do? Now it goes down and curves up. So it should kind of go like this. So that's kind of what my graph should look like. And we graphed, and that's the relationship of f, f prime, and f double prime. You guys want to see if we're right?
Yeah.
Yeah, okay. So now let's look at this. If I hit graph and I turn my function on, let's see how close we were.
Close enough.
Oh, yeah. Great. Oh.
Wow, Mr. Adams just... But we studied the behavior of the graph and we got it right. And it's all based on prime and double prime. So now, what does that mean? If I turn the graph of f double prime on,
I think that's we got that answer 20 minutes ago.
notice that the max, the local max occurs when this is at the x-intercept. Notice that the minimum occurs when this is at the x-intercept. Now, our point of inflection, here's the weird thing, the point of inflection occurs at our at f prime's local min, which occurs when f double prime is at 0. Does that make sense? The concavity of this line here curls down because from here to here, it's negative. Here it curls up because from here to here, it's positive. From here to here, f is increasing, but from here to here, f is decreasing. And from here to here, starting at this point here, f is increasing again. Are there any questions? Okay, that's it.